Hi, Dr. Harris here, and with our first video from Chapter 3 of our data computing course, we're going to be looking at a few videos where we go through a couple of slideshows on the grammar of graphics. And so let's jump right in and see what we're going to do. So we're going to be looking at this picture. We already saw it at the beginning of our slideshow for Chapter 2. But now that we've talked about what we're going to be doing in this course, maybe we have a little bit of better sense of what this picture represents. We are going to work on visualizing here at the beginning of our course. We'll be talking about transforming data sets, tidying data sets in chapters 4 and 5, and then we'll be working on the modeling part later on in the course. And so this gives us a sense of the types of things that we're going to be doing in terms of trying to generate good data graphics and also make sure that our readers can understand what it is that we're trying to do. So, but this chapter 3, is specifically about a particular package which allows us to generate graphics, and that is ggplot2. And so if you go to the packages portion in RStudio, you'll see that ggplot2 should be checked for you already here. That's the place that's going to have the function ggplot, which we're going to be working a lot with in this chapter. And so everything that's there is available for our use. And so to execute functions using this graphics package, we need to begin to understand the structure and the concepts that are going to be involved in putting together these commands that will allow us to generate graphics. We'll start fairly basic, but we will grow pretty quickly as well. And so we want to talk about frame, glyphs, aesthetics, scales, and guides in this video. So let's do it. ggplot2 was written in large part by Hadley Wickham. I believe he's from New Zealand. You can see what he has to say about how he might describe ggplot2 in short order, and basically saying, might not be able to do that. But you can see the link here will take you to some online documentation. There is also a cheat sheet for the use of commands in ggplot2. I've posted a link to that cheat sheet on our course Canvas site. You might want to take a look at that and maybe print one out for yourself. So let's talk about the frame. And you have a sense of what the word frame means in terms of artwork. It's the external part, the part that surrounds the picture, the painting, the art. And you might think of that similarly here in ggplot, what the frame represents. And so it's going to help guide us on how position is related to our data set. And so you can see here what frame is going to do for us in terms of visual cues of location. So let's see how we're going to set up the frame using the command ggplot. And here's the general form that we've got in this top gray spot. We're going to give the name of our data set, and then we've got this % greater than % symbol, which we're going to talk about in just shortly. And then we finally get to the command ggplot, and inside it, we've got this 3-letter sequence called AES. We'll describe what that is shortly. And then for starters, we'll indicate what variable is going to be represented on the horizontal axis and what variable is represented on the vertical axis. And I give you an example below. If we're using the M111 survey data set, then we use that % greater than %, ggplot, AES, parentheses, X equals fastest. So it's going to represent the fastest speed we've ever driven. And I talked about this in class. And then Y is GPA. So we're actually going to be generating something related to a graphic that we saw in the video, in the slideshow for chapter 2. So, but when we execute this command, if we were to do this in RStudio, and so I'll go ahead and copy and paste this command into RStudio here, we'll see that we don't get anything except the we get a frame, and so we've got the grid lines, we've got the tick marks, we've got our axes at least rudimentary labeled, but there's no data values here. So all we're doing is we're setting up the framework on which we're going to put the rest of our graphics. And so data set, percent greater than percent, ggplot, AES, tell what the X variable is, tell what the Y variable is, just sets up the framework for what's to come. And so that's going to be the first thing that we do when we want to generate a graphic. We'll call ggplot and set up this initial framework. So let's talk about a couple of these pieces. And so I'm not going to call it percent greater than percent anymore. I'm going to call it the pipe. And we're going to be using the pipe a whole lot in this class. For right now, we want to be thinking about the pipe as a way to string a function put a function or a collection of functions in some successive order to bear upon a data set. And so we've piped the command ggplot onto the data set M111 survey in setting up that initial frame. And then what's AES? We're going to be talking about aesthetics a whole lot in this class. And so when we call AES immediately after starting a ggplot command, what we're doing is we're setting up the frame. We're indicating which variables are going to be arranged on the horizontal and vertical axes. So we're going to be seeing AES in various forms inside the command ggplot. But if it's AES just inside ggplot, all we're doing is we're setting up what variables are going to be on our horizontal and or vertical axes. Here's an alternative way, and this is something that we see in chapter 3 in the text, a way of coming up with setting up the framework for ggplot. We can put the data set inside ggplot as an argument, and we can assign the output of ggplot to a variable. And so the less than hyphen, we want to think of that as an arrow, an assignment arrow. And what it's going to do is it's going to take the output of this command and stick it in the variable G inside RStudio. So that's an alternative way. You'll see that in the text some. We're going to try to focus on using the pipe in this class. So now let's talk about glyphs. You may be familiar with the term glyph. We think about glyphs as symbols. And so these are going to be the units which represent our data values in the graphic. And so this is the way we're going to get actual graphics in our frame. And we're going to see a lot of different commands throughout chapter 3 for generating glyphs. We're going to mostly, in this video, this part of the slideshow, work with geom point, and we'll see that momentarily. So if I wanted to add the coordinate pairs corresponding to fastest speed ever driven and GPA to the frame that I've already defined, we're going to add the command geom_point to our graphic. And so we pipe ggplot onto M111 survey, but then we add to it other graphical elements. And so we're going to be using the plus sign when we want to add things to our plot. And so we're just going to plus and then geom underscore point, open parenthesis, close parenthesis. We're not doing anything besides just plotting the points on here. And so we'll see in the next slide what we get, but let's go ahead and see what happens when I copy and paste this into our studio. And so what I get when I add geom point, well, it adds all the points in. And so the aesthetic above, x equals fastest, y equals GPA, tells it that the coordinate pairs I'm to add have x coordinate corresponding to the fastest speed ever driven in the M111 survey data set, and y coordinates corresponding to the GPAs. And so we see that in this slide as well. So we get a scatter plot when we add geom underscore point to our ggplot. Again, we had to have those aesthetics for what lives on the what lives on the horizontal axis, what lives on the vertical axis before we could do this. So, but now we want to expand and understand that we can do more with aesthetics than just define which variables go on the horizontal and vertical axes. We can actually add aesthetics to our points. And we're going to see that in the next slide, next few slides, that we could add aesthetics for, in this case, we're going to show examples for size and color to our graphic. So let's see how we use the AES command inside geom underscore point. If I were to say I want the aesthetic color equals sex applied to the points, that's what that's going to do, is it's going to assign colors to each point in our plot based on the response in the variable sex in our data set. And so we're going to get a different color for males and females in this plot. And this is the graphic that we actually saw in our slideshow for chapter 2. This is the command that was used to generate that graphic. We used a ggplot where we set fastest on the x-axis, GPA on the y-axis, and then we threw points in there using geom underscore point, and then we attached an aesthetic to the color of the points depending on what the sex response was for each individual in our data set. But I can do more. I could not only do color for the sex of the respondent, but I could actually attach a size based on the height of the respondent. Height is another variable that lives inside M111 survey. And so if I do size equals height, that's going to assign a different size to the points based on the reported height of the respondents. And so we see here, we've got a little legend over here that gives us what the size dot we get for somebody who reported being 60 inches tall and what size dot for somebody reporting being 70 inches tall. But we see that there are dots smaller than that for 60. So those are people who reported being shorter than 5 feet. And then we've got some that may be a little bit bigger than the 70 inches as well. So those would be people that were a little bit taller than 5 feet 10. And so we see that we've got different sizes based on the height of the respondent as well. So we can ascribe various aesthetics to the points as well. So now let's talk about scales and guides for a moment. You can see here that scale is going to say something about the relationship between the value and a graphical attribute that's going to be displayed based on that value. And what we're going to do is I'm going to use a different scale for color based on the respondent of the sex of the for the previous graphic. We can see that the default choice, since I didn't describe a desired scale, R used a default scale where it used that darkish red for the women and the turquoise blue for the men. I could make my own choice, and you can see here that I can add scale underscore color underscore manual. So I'm setting the scale, the colors manually here, and this way I'm going to make the females orange and the males brown using this construct here. And we know that the females come first because female comes before male in alphabetical order. So we're going to use lexicographic order for the values of the categorical variable sex here, female then male. So orange is going to go to the women, brown is going to go to the men. So I'm adding my own scale to this. And so we can see that indeed I get orange dots for the women and brown dots for the men when I do that. Let's look at a different type of scale for another example. Let's look at the data set world cities. And I can use question mark world cities to learn something about it inside RStudio. So let's copy and paste this in. What this does is it helps me look at bringing up the help file, and I'm wanting the one cities and their populations from the MDSR package. So I'm going to click on this one, and we can see it lists cities, and it gives a city code, the name, latitude and longitude, a code for the country, a code for the region, what the actual population of the city is at some point in time. And then it gives the date on which the estimate was made, some other codes as well. I'm going to be interested in latitude, longitude, and population in this particular case. And I've got world cities over here. We've got the city code, we've got the name for it, latitude and longitude, and the main one thing I'm interested in here is the population. So let's draw a graphic for population in world cities. And I'm going to use longitude. So I'm going to use its location along the equator to try to, with respect to along the equator, to be the x coordinate, and the y coordinate is going to be population. And let's go while we're at it. Let's do an aesthetic. So we've got the pipe applied to world cities here. ggplot. We use AES to tell what variables are going to be along the horizontal and vertical axes, and then we add to it geom_point, so it gets my points plotted, and we're going to add an aesthetic to that, where we're going to color it by latitude. And so rather than generate that in RStudio, let's just go ahead to the next slide and see what we get. And so we can see here that we've got a legend for latitude. Cities that are far south of the equator are going to be in almost a black color, and a lighter blue for the ones that are far north of the equator. And so we see a mix of things. And here's longitude 0. That corresponds to, I guess, Greenwich, England, I think. And then this is going west. This is going east until we meet at 180 on the other side. And so we can see here there's a little bit of a gap. This is probably where the Atlantic Ocean is. And then we've got bigger gaps over on the ends. That's probably where the Pacific is. So we've got very few cities at these longitudes. But what we see is we've got a whole pile of cities near the very bottom. So let's look at this vertical scale for just a minute. 5.0 E plus 0.6. So we want to remember that this is scientific notation. So this is 5 times 10 to the 6th power. 10 to the 6th is a million. So this bar corresponds to 5 million individuals. 1 times 10 to the 7th is 10 million. And then this would be 15 million up here. And so what we see is we've got a whole lot of points that are, it says very close to 0, but they're certainly well below 500 million, 500,000, sorry, below 500,000. So the question is, do I want to use a linear scale for city population? And so let's explore what we might do to do that, to try to space them out a little bit. And this is we're going to see that this is not entirely satisfactory. And so we're going to add to this, we're going to use a logarithmic scale, and we'll use a log base 10 scale. And so the command we apply to do this is scale_y_continuous. And then trans is transformation. So we're going to transform our data in the y-axis using a base 10 logarithmic scale. So let's see what happens what happens to our graphic. And we're going to see something looks a little odd to us, or a little odd to me anyway. We still see that there's a very abrupt cutoff to our graph. There are very few cities whose populations are below this level, but this seems to be, well, let's look at it. This is 1 times 10 to the first, so that's 10. 1 times 10 to the third, that's 1,000. 1 times 10 to the fifth is 100,000. 1 times 10 to the seventh is 10 million. And so we're making these big jumps. But right here, this is right about at 1 times 10 to the fourth, which is 10,000. And so what it appears to be the case is that there aren't very many cities entered in our data set that have populations below 10,000. It's almost as if 10,000 was almost a cutoff for being included in this data set. So let's take a little bit closer look at the populations. And if we scroll through it, I'm not going to go through all 23,000 entries, but if we scroll through it, we see a lot of figures between 10,000 and 100,000. And we're not seeing anything initially, at least, below 10,000. Oh, here's 2,035. So that's one of the points that's below. But we're seeing a lot of values that are just a little bit over 10,000, 10 to 20,000, 30,000 range. And so this is not a uniform sampling of cities. It seems like they were sort of intentionally using 10,000 as almost a cutoff for inclusion in the data set. And so while this does stretch things out somewhat, there's still an issue here. And so we shouldn't be completely satisfied with this. So I talk about this issue, and maybe we can try to make this a little nicer later on, but we are limited by the fact of what data was included in the data set to some reasonable extent. But mainly I just want to show you how we can apply a log scale to a graphic. That's the main thing we want to try to get out of it. Is if I decide that I've got a bunch of data clustered together and it would be useful to spread things out using a logarithmic scale, we want to know how to use that, how to do that. And then guides. Guides are really the main things that we're going to be doing to supply context to our graphic. And so that's going to involve labels and tick marks. We can define what those are. We can add legends. Sometimes those will be added by default, as we've seen, but we can also actively add guides to our graphic. And one way we can do that is with the labs command inside ggplot. And so we're going to add to our plot where we've split men and women apart by color in the graphic. We can add labels. If we say x equals, that's going to label our x-axis. Y equals, whatever's in quotes is going to be labeled for our y-axis. And then title and subtitle are exactly what you think. They're going to supply a title and subtitle to our graph. And so if I were to run this, you'd see that indeed I'm adding fastest speed ever driven, parentheses MPH, as my label on the x-axis. Grade point average replaces what I had previously as my label for the vertical axis, and my title and subtitle go up here. The legend was supplied automatically for us. So just to briefly recap what it is that we've done so far for the base product for a graphic, we're going to describe the frame, call ggplot, and define aesthetics for our axes. We're going to choose a glyph, and so it'll be geom underscore something, and then we will add aesthetics, if we so desire, to that glyph inside the glyph call. And then lastly, we'll add on labels. And if we want to do some layering, which we'll be talking about in our next slideshow, our next video, we will repeat steps 2 and 3. And so that's the basics for right now. We'll move on to the remainder of the slideshow in our next video.